Hey everybody, welcome back to Mr. Elko with the Mathtub. Today we're going to be looking at the second part, which is finding an equation from a graph. So this is the graph that we're going to be using for this example. Hopefully you can see it fairly well, but I went by single digits here. And I have 3 points, and we'll talk more about those points here in a second. So we're going to be using the vertex form, and we're going to be needing this graph, and we need to get to the actual equation that creates this graph. So here's what we're going to do. So first thing is we need to identify our vertex, which is our h and our k values. So if we look at our graph, our vertex is our highest or lowest point that we can find where our parabola reaches our peak and then starts to either reverse or increase again. So here I have my vertex right in this location, and its coordinates is -3, 2. So now these coordinates are very important because it's -3, 2, we can use our h value and our k value can be filled in from that vertex point. So that's what I'm going to do. So I'm going to take my h value and I'm going to plug it in here. So that's going to be a minus -3. So we don't represent it that way. We actually represent, because we have a negative and negative, it actually becomes a positive. So it's going to represent +3. And then our k value is +2. So I'm going to replace it with +2. Now everything else I'm going to leave the same. I'm not going to change anything about it. So now, this is the second part. We're going to need to find another point that's easy to identify for us. So here I have some zeros, and I'm going to choose one of them. So here I actually have one going through the origin, so I'm going to use that. So if you don't remember what the origin is, that's 0, 0 is a coordinate. This one over here is -6, 0. And we can use that one as well. And if you want, I'll run the second example if we have time, so you can see how they both work. So I'm going to use the 0, 0 coordinate, the origin point, as what I'm going to use. So how we do it is we take our x value and replace our x value, just like we did in the last example using substitution. So I'm going to get rid of this x, and I'm going to replace it with whatever my x value is in the coordinate I've chosen. I'm going to do the same thing with y. So I'm going to get rid of y here, and I'm going to replace it with 0. So now, all I have left is my a value. And now we need to isolate it. So we have to go through order of operations. We're going to start to solve inside our brackets first. So we know that 0 equals a, 0 plus 3 gives us 3 squared plus 2. Then we're going to do our exponents. So 3 squared gives us 9. So we have 9a plus 2 continues to equal 0. So now I'm going to get rid of this because I need to isolate my variable all by itself. So in order to do so, I have to do the opposite action. So the opposite of adding 2 is subtracting 2. These will cancel out, and I'm going to be left with -2 equals 9a. Okay. So now we're getting into our final part. I'm just going to set up my calculator because we're going to need it for this part here. Okay, so now we need to get rid of this 9. So how we do that is we are going to divide by 9, divide by 9. These are going to cancel out and leave a all by itself. So now all I'm going to do is I'm going to take my -2, divide by 9, and I end up with an answer of -0.222 repeated. And on and onwards it goes. So this a now gets plugged back up here in my original equation. So I'm going to go, it'll be -0.222 repeated. Actually, let's make this a little bit more proper. So y equals -0.222. Now because I know my h value, we've already figured it out. I'm going to delete that. And I know my k value. So now I've gone through all the processes. I have found my a, I found my h, and I found my k, and I now have my equation that gives me this graph. And if you ever want to prove, you can take this equation, plug it into one of your Desmos programs, or graph it yourself again using the table of values, and you will come up with the graph that creates the exact same version of this. And if we choose the opposite,